notes is about solving with variables on both sides of the equation. So when we're working with an equal sign, we are doing things in reverse PEMDAS order, which is SADMEP once again. So for our first example, we've got 6x plus 2 equals negative 10. For our first step, we are going to subtract, because that comes first in SADMEP, from both sides. Remember to do the same thing on both sides, balance the boat. So we've got 6x equals negative 12. That 2 minus 2 makes a 0. It doesn't just disappear. Then we divide both sides by 6, and we get x equals negative 2. To check our answer, which is something that we've kind of breezed over a little bit lately, you need to plug negative 2 back in for x and see if it actually ends up giving you negative 10 on both sides of the equal sign. For here, it does, so we were good. Number 2, we've got 9c plus 4c minus c equals 48. So here we need to combine like terms first. So 9c, 4c, and negative c are all like terms. They add up to 12. So we've got 12c equals 48. We need to divide both sides by 12, and we get 4. So we plug it back in to check our answer. So we've got 9 times 4 plus 4 times 4 minus 4. And we want to see if that left side of the equal sign equals 48. It does, so we're good. So the next one, we've got 2 times x plus 5 equals 18. First step here is going to be to distribute that 2. So that gives us 2x plus 10 equals 18. Then we subtract 10 from both sides to get 2x equals 8. Then we divide both sides by 2. So we are going in reverse PEMDAS order. Then we check our answer by plugging 4 back in. So it's 2 times 4 plus 5 equals 18. So that becomes 2 times 9, which equals 18. So there's also another way to do this problem. It'll depend on your algebra teacher, which way they want you to do it, or just whichever way you're more comfortable with. So we could have divided both sides by that 2 first, taking into account that parentheses come last, which gives us x plus 5 equals 9. And then we still get x plus 4, which is the same answer. So both ways work. Number 4, we've got 3 times m plus 5 minus 2m equals 10. So first we're going to distribute the 3. We've got 3m plus 15 minus 2m equals 10. Combine like terms. Then we get m plus 15 equals 10. And when we subtract 15, we get m equals negative 5. So then we check our answer by plugging in negative 5. Negative 5 plus 5 equals 0. So we end up having just negative 2 times negative 5, which equals 10. So we are good to go. So here's some harder examples. So the first one, we've got 5x equals 8 plus 3x. First, we need to get our variables on the same side, which is going to add a step to our steps that we're going to end up writing down. So make sure you guys are copying this down. You're going to need to reference these later whenever you're doing homework and stuff. Press pause if you need to. I know I'm going fast. So to get our variables on the same side, we're going to subtract 3x from both sides, because that makes us have a positive 2x on the left side, and we end up getting x equals 4. There is another way to do it. We could have moved the 5x over to the other side. So if we subtract 5x, we end up getting 0 equals 8 minus 2x. And then we're just solving our equation from there. So we subtract 8 from both sides, and then we divide by -2, giving us the same answer. So it really doesn't matter which side you move your variables to, as long as you are comfortable solving each way. It is obviously easier to move it to where your variables will be positive or have a positive coefficient. We're plugging 4 back in to check our answer, and we're good to go. Make sure you guys are especially checking your answers as you go. Make it a habit. For number 2, we've got 8x equals 2x plus 6. I decided to subtract 2x from both sides, so I have a positive 6x on the left side, and we end up with x equals 1. The other way to do it would be to move the 8x over, which is going to end up being more steps, but we're still going to get the right answer. So we could have subtracted 8x from both sides to get 0 equals negative 6x plus 6. Subtract 6 and then divide by negative 6, and we're going to get positive 1 as our answer again. So same answer both ways. One ends up being easier than the other, but know that if you move it the wrong way, or to a negative side, you're not doing anything wrong. It just might be more steps. Here's another example. We've got 5 minus 3y equals 2y. So I decide to add 3y to both sides, so I have a positive 5y on the right side. Then we just divide both sides by 5, and we get 1 equals y. The other way to do it would be to move the 2y over, and we get 5 minus 5y equals 0. Subtract 5y, and then subtract 5 and then divide by negative 5. And we get positive y, or positive 1 for y again. And then you plug it back in to check your answer. Number 4, 8a minus 5 equals 3a plus 5. So I'm going to move my 3a over so that I can have a positive 5a minus 5 equals 5. Add 5 to both sides and then divide by 5, and we get a equals 2. The other way to do that would be to subtract 8a from both sides, giving us negative 5 equals negative 5a plus 5. Then we end up subtracting 5 from both sides and then dividing by negative 5, which is in front of the a, and we get positive 2 again. When we check, we plug in our positive 2, which was our answer. We want to see if we get the same number on both sides. 11 does equal 11. Yay! Last page, I promise. Here's some more hard examples. So we've got 7c plus 9 equals 7c minus 31. See if you notice anything weird about this problem. When we subtract 7c from both sides, we get 0 plus 9 equals 0 minus 31. And then we get 9 equals negative 31. Since those things are not equal, that means that we write the answer no solution. That means that no matter what you plug in, that problem is not going to work. You can try literally any number and plug it in for both c's. That equation is never going to be equal on both sides. If they were equal, then we would write infinitely many solutions. You guys will see that coming up. So for this one, we've got 7 plus 3x minus 12x equals 3x plus 1. We combine like terms first. Then I'm going to add 9x to both sides. Obviously, you could subtract 3x too. Subtract 1 from both sides. I get 6 equals 12x. And then I divide both sides by 12, getting 1/2 as my answer. Make sure you simplify your fractions. Another number 7. 5 times x minus 3 equals 15x minus 15, or 5x minus 15. Distribute that 5, you end up having the same thing on both sides of the equal sign. So since it's the same, since both sides are equal, this is when we write IMS, or the R with the extra leg, which means all real numbers. So depending on what your teacher wants you to write, you can write either one. So IMS stands for infinitely many solutions, and the double R means all real numbers. Last example. So we've got 2/3 times 3x plus 9 equals -2 times 2x plus 6. So first we're going to distribute that 2/3. You can multiply that in your calculator. And we're going to distribute the -2 on the right side. Then we're going to add 4x to both sides to have a positive 6x on the left side. You could subtract the 2x from both sides and have a -6 on the right side, and you will still get the same answer, which is x equals -3.